NASA engineers are turning to AI to help design customized parts that are more advanced than ever.
With the emergence of artificial intelligence, AI, space exploration has become more efficient and accurate than ever before.
Like many other industries, the space exploration process is also adopting artificial intelligence.
In 1957, the first ever attempt of space exploration began, where the Soviet Union launched the first ever satellite to explore the vast abyss within the sky. And we've come so far since then, with NASA launching endless spacecraft. But have we really discovered anything? Are we really alone in this universe? And these days, $1 million question would be, what if AI could be the key to unlocking the mysteries of the hidden worlds in our universe? NASA already believes it is. So sit tight as we're about to discover if AI can really turn science fiction into reality. You're watching MetaRise channel, where we cover all the thrilling new developments in the metaverse, virtual reality, and AI. So if you're up for an exciting ride into the tech world, make sure to hit subscribe and turn the notifications on so you never miss out when our next video goes live. Now let's start today's episode with the inception of AI in space travel. Let's give you a blast from the past about when and how NASA began to play around with AIs for space adventures. Take a look inside NASA's Jet Propulsion Laboratory. Here, the researchers embarked on a groundbreaking research. Here, researchers began on a great mission to harness the power of AI for space exploration in 1960. They experimented with rudimentary forms of AI for things like autonomous navigation, where a rover would be able to make its way through space on its own so as to convey back new discoveries without the need of humans to go physically to control those machines. But it was not quite that simple and easy as is the case in trying out complex technological things. If you look at the fact that the nature of work in space travel involves communicating over vast distances and issues with cosmic radiation, making it difficult for scientists to monitor the journeys of their spacecraft. The astronauts who are brave enough to risk going into the abyss, we all must have wondered how difficult it must be to live in space during missions. Living alone and in a completely different environment can make you seriously lonely, and that is if they don't get sick, which is a whole other struggle. And this is all just the tip of the iceberg, because we all know how NASA has been accused of wasting millions of taxpayers' dollars towards failed rocket launches and missions. And if you think about it, it shows how it was incredibly difficult for us to reach outer space, let alone reach the moon or Mars. This is where artificial intelligence serves as the beacon of hope for us to be able to explore not just Mars or the outer planets, but also other galaxies. So let's give you a little ride into the timeline of how AI has served as a guiding star by aiding our scientists in hitting one milestone after the other. Starting off with the Ranger 7 mission, for example, which began in 1964. For the first time, AIs helped guide the spacecraft's trajectory, or path, to be able to capture unprecedented images of the moon's surface. Fast forward to the 1970s, the AI journey took one step further with the Viking missions. These missions employed AI to analyze soil samples, which would give the landers a head start in deciding which samples to prioritize for study. And NASA certainly didn't stop there, as more and more developers were shaping AI into increasingly functional advancements. NASA deployed more missions like Voyager and Galileo throughout the 1980s and 90s. The newer AI integrations were beginning to identify and respond to unexpected events in the journey through the cosmos. Skip to the 21st century, and the marriage of AI and space travel has become even more pronounced with our spacecrafts now crawling on Mars, and on their way to Jupiter with NASA about to begin the Europa Clipper mission in 2023. But more about that later. For now, the Mars rovers, Spirit and Opportunity, have shown remarkable autonomy by making real-time decisions on exploring the Red Planet, and sorting out any scientific targets for us to study. One cool example would be the Curiosity rover that utilizes AI algorithms to analyze rock samples and prioritize areas for exploration. What's more is how AI's influence is also felt on board the International Space Station. Yes, technologies like Simon are aiding astronauts in providing information, guidance, and even companionship, because as we mentioned before, it can get lonely and stressful sometimes. But perhaps one of the most baffling milestones would be the discovery of exoplanets using AIs trained on NASA's Kepler telescope data. Now, for those of you who don't know, exoplanets are any planets found outside our solar system, like those orbiting other stars, or even rogue ones float freely. All of these missions require integrating AI in multiple different fields of operations conducted by NASA. So let's take a deeper look at the various quests that scientists and AI are collaborating on every day to reach the stars. NASA intends to launch the Europa Clipper mission, a robotic explorer that will investigate Jupiter's intriguing moon Europa in 2023. The goal of this mission is to examine Europa's ice shell and innards to learn more about the moon's composition and geology, among other complexities. The primary goal, of course, is to determine whether or not life might exist within Europa's inner ocean. This raises a number of issues, many of which stem from the fact that the Europa Clipper will be operating at a great distance from Earth when conducting science activities. To solve this, a team of researchers from NASA's Jet Propulsion Laboratory, JPL, and Arizona State University, ASU, created a set of artificial intelligence algorithms that will allow the mission to explore Europa autonomously. This isn't just about getting to explore outer space without having to go ourselves. Communication with deep space missions is quite laborious and takes a lot of time for people working at NASA. When interacting with missions, say, on Mars's surface, a signal can take up to 25 minutes to reach us and vice versa. Sending messages to Jupiter, on the other hand, can take anything from 30 minutes to an hour, depending on where it is in its orbit relative to Earth. So spacecrafts are often sort of given a to-do list rather than controlled on a joystick, as we would like to imagine. This method is particularly successful when the spacecraft's location, environment, and other parameters are known, or can be predicted in advance. But this also means that we won't be able to respond properly in case of any unforeseen event. So now scientists are investigating potential methods for onboard data processing that may be used wherever and whenever direct human control is not feasible. So the AIs are fed with the observations of dust devils on Mars, meteorite strikes, lightning on Saturn, and ice plumes released by Enceladus and other bodies. So they'll be able to predict it during the Europa Clipper mission. Moving on to the second big mission that AI is employed for: spacecraft maintenance and health monitoring. As a mission's design and planning needs enormous knowledge and experience from all human and computer assets involved, AI can assist in managing information, knowledge, procedures, and operations throughout a space mission. One of the first things that AI does in mission design and planning is collecting records of useful data from previous missions. This is important because these records aren't always completely accessible, and so researchers are developing an engineering assistant with AI to collect and evaluate important data and offer trustworthy responses, which saves us humans a lot of effort and time. Take a look at this study about Daphne, design assistant being turned into an AI companion for mission designers. It develops designs of the Earth observation satellite systems. To do that, it mostly uses something called natural language processing to analyze the strengths and weaknesses of designs presented by engineers. It will then remark on their effectiveness. It's just like in the popular animated movie Ratatouille, where this AI is Anton Ego critiquing food. Another major hiccup for NASA is the monitoring of satellite health. NASA wastes millions of dollars on failed rockets mid-air. Onboard AI capabilities can help with this problem as well. The functioning of equipment and sensors is constantly monitored by a system capable of providing useful information such as alarms. This predictive capability can allow mission controllers on the ground to take corrective actions before problems escalate. So now the taxpayers' money isn't all wasted thanks to AI. It's one of the most researched topics in aerospace engineering. For those of you who don't know, optimizing spacecraft trajectory is basically the development of a projectile or projected spacecraft's route that meets specific criteria, considering the specified beginning and terminal circumstances. Now, there's an interesting class of AI algorithms called evolutionary algorithms, such as insect colony or genetic algorithms, where the dataset is based on evolutionary aspects of nature. Studies have shown that these are great to discover feasible solutions to problems that require more efficient systems to solve. So if we look at trajectory optimization, the goal can be anything, from getting good shots of the moon in 1964 to being able to reach different milestones in the cosmos. And even though these algorithms are highly adaptive and suited for this, their results aren't quite predictable during various runs. Yet it has been successfully applied to get great outcomes like planning rendezvous for astronauts in space, as well as routes to travel between orbits and planets for the rovers. We're all aware of how satellites create vast amounts of data. Let's give you an example. Take Maxar Technologies, a Colorado-based space technology business that has more than 110 petabytes of picture data. And that's not all, because they get 80 terabytes added every day. Now, AIs can come in handy for processing all this data in less time, not to mention more accurately. Machine learning algorithms can analyze changes in millions of photos in real time. By using AI to automate these procedures, satellites can capture photographs on their own when sensors detect certain signals. This was put to a test by Leeds University in the UK. They studied photos taken by the European Space Agency's Gaia spacecraft and used machine learning algorithms to the data. The results were fascinating. They discovered over 2,000 new protostars. These are essentially young stars, growing among gas and dust clouds. And finally, AI can also help and regulate astronauts' wellness during missions. Check out sentiment analysis, also known as emotion AI or opinion mining. This will extract and recognize opinions from text data, such as reviews, forums, social media, and other sources. These AI buddies will then recognize and anticipate the crew's demands and needs, including mental health and emotional support. Think of how helpful this could be in the case of emergencies, just like the AIs helping in healthcare, which we covered in a previous episode. Now, if we take a step back, there seems to be a lot of accomplishments coming from AI, but the struggles aren't talked about as much. Because everything that seems unusually great comes with a cost. Chugging a glass of coffee gives you a crash later. Eating a lot of sugar gives you diabetes. So is there a catch when it comes to AI and space travel? What are the challenges to use such a technology? Because the experts have argued that the level of deep intelligence humans perform is difficult to emulate in software. The mismatch between perception has primarily been examined from a deterministic perspective, leading to reactive rather than intelligent behavior in robotics and aerospace. And if you have an idea of the concept of how data and information are two different things, you would know why many AI models will most likely never be able to achieve a 100% accuracy in their operations. This is exactly the same thing where humans have perception, and we think by converting data to information, rather than operating entirely on observation and repetition. We make an idea of things in our head after we collect data, and then test it in our head under different possibilities as well, using our senses. AI, on the other hand, doesn't have senses, as it's just an algorithm and works completely differently. For instance, UAV or autonomous aircrafts, whose main task is to search and track objects of interest, tend to lose track of extreme targets during military missions. If you apply this in space tech, there is always a chance of things being missed out. But there's still a decent amount of successes, and the proof of that lies in what could be considered one of the most astounding discoveries that we probably could have never done without AIs: finding exoplanets. Humans have always fantasized about finding the alien species, and if you're a millennial, you'd remember the infamous Arnold Schwarzenegger film called Predators, or perhaps Aliens vs. Predators. Both of these made us think hard about the existence of aliens, and how likely it is considering the sheer vastness of the universe. So to answer this burning question, NASA gave AI an objective to study the changes in starlight produced by transiting planets. The famous Kepler Space Telescope integrated AI algorithms to discover probable exoplanets. Now, these algorithms were critical in sorting through huge volumes of data in order to detect minor signs that could point to the presence of exoplanets. This AI software differentiates planets from non-planets using a dataset of over a whopping 15,000. tagged Kepler signals. Now, from this dataset, it had to distinguish between patterns created by genuine planets and patterns caused by other objects, such as star spots and binary stars. When the AI began sifting through and working on new signals, it accurately recognized which signals were planets and which weren't, and with a mind-blowing accuracy of 96%. As of now, we have discovered around 5,000 exoplanets. All credits to this incredible AI system. So to sum it all up, it's been one hell of a journey. And with AI by our side, the quest is far from over. Because NASA is about to send AI robots to the moon to carry out missions without humans. They're supposed to choose their own leader and do their jobs by themselves. What do you think they'll do? Will they be able to discover anything new? But most importantly, what do you think is the next frontier for AI in space? Do tell us in the comments below. Also hit like if you enjoyed today's episode and subscribe for more hot topics in the tech world. Let's see you all in the next one. Cheers, guys.